core. Okay, now we're recording. So in Galveston's case, this includes the urban core, Galveston Island Vacation, and Boulevard Island Vacation submarket. So, looking here at the map, this is just a figure from the paper. This the central part, the kind of light orange, is the urban core, which we're considering the primary housing markets, the people that live and work there in Galveston, and then the Galveston Island Vacation, or kind of this West End plus the East End, and there you got a lot of vacation and seasonal housing, and then you've got Boulevard Island Vacation, which is out here as well. So the original models used publicly available data, namely from the tax assessor and the census. Our models, or the models that were in the paper, were panel models using that data from 2018 to 2008 to 2015. It predicts the annual building value change with respect to a kind of a suite of variables and known correlates of damage and recovery patterns. You can see the citation if you want to go look at the original paper. This slide shows the original formulaic representation of the models, the regression results, and an example of predicted building values indexed to 1 in the base year. So you can just see how building values do change with time. You've got an initial drop due to the Hurricane Ike impacts, and then recovery of building value as repairs, restoration are made to the structures. These were the models. This is, again, just lifted from the paper. You see, they estimated, I want to say this part was, Sarah, Walton, Shannon, their paper. There were these models separate models for urban core, Galveston Island Vacation, and Boulevard Vacation. So panel model, dependent variable is log of structure value. So if you've done work with property values before, and the tax assessor, you'll see that there's usually a total improvement or total property value, which is comprised of land value plus the structure value. So after a disaster happens, the land is not necessarily impact, so you wouldn't expect value to go down there, but the structure is impacted, so you would expect the value of the structure to change. So the dependent variable is log of the building value, and then the suite of variables after that in this panel model. So taking that work that was done, previously published, we've recently ported the models over into NCORE, which is essentially what I'm here to talk about today. The 2 models are available for single family housing, one for primary housing markets and the other for seasonal vacation housing markets. When you go back and look at the original models that were in that paper compared to the models that we've ported over to NCORE, there are some changes that we've done to generalize their predictive application across communities, assuming that communities have varying characteristics. Specifically, we combined non-Hispanic Black Black and Hispanic into a single minority race category. Originally, these Black and Hispanic were separate estimated coefficients. Now we've combined those together into one minority category, so that minority can be different based on the community. If there's a strong Native American population there, you might want to include those in the minority category as well. So it allows for that generalizability. The primary housing market model is based on the Galveston urban core model. The seasonal vacation housing market model is based on the Galveston Island Vacation. Additionally, and this will make a little bit more sense later when I kind of go through an example, but we take, we estimated the model, we have that model available for prediction, and once you get the prediction, you get predicted building values for each year, a number of years. Then we take those predicted building values and index them for generalizability to other communities, because the model that is implemented, in INCORE, the coefficients are calibrated to Galveston building values around in the Hurricane Ike context. So by converting it to an index, we're able to see the change in building values, based on an index, kind of a percent change year over year, and then use that to multiply in another community, in the target community that you're wanting to forecast in, to predict in. And again, hopefully this will make a little bit more sense later. We also, the original model, we had panel model. In the paper, it was a panel model. Here, we've taken that panel model and just changed it to a mixed effects panel model with housing unit and block group level intercepts to better account for data coming from both levels of analysis. So we've got some data coming from the parcel level and some data coming from the block group level, the minority race category and median household income. So the block group level intercepts better account for those different levels of data that are coming through the model. But later, even though we're estimating this mixed effects model, and it's got both fixed effects and random effects here at the end of the equation, when you're doing the prediction for out of sample, we only use the fixed portion of the model, not the random portion. So just to note on that. So this slide just gives a comparison between the original published models that have the header of Hamadeh et al. 2018, and then the models with the header of INCORE. These are the ones that we that are ported over into INCORE. Long story short here is that there are some differences between the original models and the paper, which we discussed on the previous slide, the changes to the race categories. So you can see here in the Hamadeh et al., in the urban core, we have the Hispanic and Black. We've got estimation coefficients for both. But in the INCORE model, the equivalent model to the urban core would be the primary housing. And you can see how we're missing coefficients for Hispanic and Black. That's because we've combined Hispanic and Black into this minority category. So there are just a couple of differences, and we're going to get all this written up kind of in a document and published to Design Safe, so that documentation is there for folks that are wondering. But in terms of the coefficient values and in individual variable effects on predicting building value, these remain mostly the same. So not any real changes there. So when using the models in INCORE, publicly available data are what's used, namely tax assessor shapefiles, tax rolls, and then sociodemographic data from the census. Additionally, value loss estimates are needed. So just what was the resulting damage of a disaster and the estimated value loss per structure. Currently, we're basing those value loss estimates on Bai et al. 2009 and Tomachek et al. 2013 as it exists in the Galveston testbed notebook. So that'll make a little more sense when we open up the notebook and you can see what we're doing there. So you can see for the tax assessor data and then the demographic data, what variables are coming from each data set. So from the tax assessor data, identifying what are single family parcels. Just want to reiterate, here that these models are for single family parcels and structures only. We can produce other models later for other housing types and other property types as well. But from the tax assessor data, we get the single family, the year it was built, size of the structure, and pre-event building value. From the demographic data, we're getting median household income, percentage minority, owner occupancy, and that really comes from the housing unit allocation. So these top two variables are at a block group level, and then through the housing unit allocation, we're taking that data that is aggregated, but then through the housing unit allocation, it's getting deaggregated, and we're assigning an owner occupancy or non-owner occupancy, which you would say renter occupied, to each structure. And then also at the census tract level, we're getting whether we're getting the percentage of seasonal vacation housing at that census tract level, and then we need that because if a census tract has greater than 50% seasonal vacation housing out of total housing, then we're applying the seasonal vacation housing model to the structures within that census tract. If it's less than 50%, then we're applying the primary housing market model. And then I kind of already talked about this, the value loss estimates based on these two works. This is really just reiterating the prior slide, just in a table format, so you can kind of get an idea of the variables that are needed, the data points that are needed, and the sources. So this column right here, Hamadeh et al. 2018, this is the in-sample estimation. So just showing what data was used in the original estimation of that model. And this is what produces the coefficients that we use later for predicting out of sample. So when you go over to the out of sample prediction, we have our model, we have the coefficients, but then we need to feed data through that model. And then just based on using the Galveston test-fed notebook, this is the data that's available in the Galveston test-fed notebook, just for comparison.
Yeah, Wayne, I have a question.
Sure.
Okay, so is there anything in this that accounts for sort of global increases in housing values, such as what we've experienced in the past 3 or 4 years with you can call it inflation in the housing market values, or else just the run up in housing market values?
Right. Not necessarily. This was predicting building values. The model is calibrated from 2008 to 2015. So you've got
which there was a recession.
Right, the recession. So muted impacts. Texas didn't really have a hit to property values in that time for the rest. So that really wouldn't impact this model a whole lot. But you could do some sort of kind of quasi-experimental type thing where you add in, where you try to predict what if there were no effects like that, what would housing values be? If there was
it makes perfect sense for one of the things that we just came off of the Galveston meeting, where they're very interested in what's happening with their tax revenues, and this will do beautifully to help answer that.
It'll generate that. Part of what is going on as well too. I mean, the model is essentially generating semi-elasticities that we're working with, and then with the indexing, I'm not saying that issue of inflationary factors is not relevant, but hopefully somewhat muted. in the sense of the way we've tried to do that, as well as the indexing is also. So
Right. Yeah, I was
but it's
looking
not
for control, you know,
Yeah.
if you controlled on sort of national or state housing market values, then that would give you that kind of control. I didn't see it in there.
yeah.
So anyway, just question, comment. Thank you.
Mhm. So when I guess, let me see, did I cover? Yeah, this was just a reiteration of the slide that was before. So again, just showing data sets, and I assume maybe I can send out the slide deck too for folks that want to read into it a little bit more. So I've got some screenshots real quick, just to kind of give a quick introduction, and then we can get into a couple of notebooks that show this work. So applying the models to NCORE, you've got your initial data structure. Each row here is a parcel. You can see the variables, the columns of the data that are needed to run the estimation. So these are all the variables that are needed: value loss, effective year built, square meter, owner occupancy, and then we've got data at the block group level, which includes median household income in thousands, percentage minority at the block group level, and then at the tract level, we've got percentage of vacation, and then this last one is just a dummy of whether we're considering that tract a vacation housing market. So you got the initial data structure, taking those values for each of the variables and then multiplying them by the coefficients from the model, you get predicted building values for each year. So these are the predicted building values for each structure. And then next, we can take these building values, the predictions, and index them to produce a index per housing structure, per housing unit, essentially, in the single family case, where we see that changes in building value for each structure. So the model allows us to, for each parcel, each building, to have the building value change over time, and each one gets its own change. I think I kind of fumbled the words there of what I was trying to say, but this is essentially, this will show you. So we've got, building value index here. So, again, going back a slide, we've got predicted building values per parcel, per structure. You can see this is the predicted building value for year -1. So that's pre-disaster. Year 0, that's year of the disaster. Year 1, that's year, the year after the disaster, all the way to year 6. So that's what's being shown there. Don't read too much in these values, because I mean, you do see that the building value goes up in the year of the disaster. That's more of a function of the data that's coming from NCORE, and there's some issues there that I think as a group we need to kind of discuss of what the Galveston testbed notebook is actually showing. So don't read too much into the variables there, or into the values that are in the table. So then we can take those predicted building values, convert those into an index where the base year is equal to 1, and then you can kind of see how building value changes over time per parcel. So here you can see it goes up 80% in year 0. This one more represents one that shows value loss because of damage. It goes down, was that almost 93% in the year of the disaster. So then, I kind of alluded to earlier, the reason why we convert to the index is that you can apply this model and the predictions outside of the Hurricane Ike, Galveston, Texas context. So we use these indexes to multiply by the base year building values in the target communities. Because what you're essentially doing is, you've got a community that hasn't been impacted by a disaster or maybe just got impacted by a disaster and you want to get some kind of expectation of how building values might be impacted from the damage, and then also the recovery trajectories of those building values. And so we get an estimated change in building value per parcel from the model. We get those building value predictions, we convert them to an index, because remember, the model is calibrated for Hurricane Ike and Galveston, which Galveston's going to have much lower property levels than, say, Miami or San Francisco. So those predictions of 60,000, or let's go here to this first year, 30,000, 60,000, 50,000, probably don't apply much in those cities. But the change does. So we're taking those indexes and multiplying them by the base year in the target community. And when you do that multiplication, then you get a per parcel change in building value over time. So that's kind of a real brief overview, if you want to call it brief, from kind of start to finish. And then we'll go back through this again now in there's 2 Jupyter notebooks. I've got one that I'm going to be primarily showing that is my development efforts in Google Colab. It's basically what I did in order to take the models from the paper and then convert it to code, do a proof of concept so that I can then communicate to NCSA and say, here's what we're trying to accomplish. And then we've got the production notebook that's currently in GitHub, and here's the kind of path and link to it that you can see that's out there, that takes my hundreds of lines of code and converts it to less than 50 lines of code. So I'm going to hop over into that question. How are we doing on time?
We're doing really well. If you want to, we're at the bottom of the hour. Usually we go, for another 20 minutes with, you can continue a few presentation or take some questions now. It's up to you.
Okay, let me hop over to this notebook real quick, and then I'll kind of roll through that, and then I'll try to wrap up here in 5 to 10 minutes.
Perfect. Thanks.
So here, so first notebook was just the notebook that I was using in kind of my development efforts to kind of port the paper into Python code. I've got it opened up in Google Collaboratory, not Jupyter Notebook. I'm actually having a little bit of issues with Jupyter Notebook on my computer, and that's just because I haven't opened it for a long time. So I'm sure I need to do some reinstallation and updates and stuff. But luckily, I've got everything cached here in this notebook, and then also in Core, the one that Mikal put up there. You can go through this too, and it's got all the output for review. So back to this notebook. So all I did essentially was download at the time what the current Galveston testbed notebook is, so that I can try to integrate this housing recovery model, housing value recovery model in there. And so I guess one thing I do like about Google Colab to work out of is just kind of the simplicity of it. Just being able to launch it up in the web browser. And I really like the table of content, so it helps me kind of bounce around between sections, but you can't use it with Core. It doesn't install certain packages and stuff, and then other applications too. It doesn't work as well. So definitely Jupyter Notebook is the one that's more expansive, but Google Colab kind of is useful for these kind of efforts. So you see, I've just, again, we've got, flood, surge, wave, inundation models, Galveston building damage, Galveston housing unit allocation, and then I think as it is now published out there, I think Galveston population dislocation is the last analysis that's in the Galveston testbed notebook. And then I tacked on the housing recovery model here at the end, because I'm chaining this analysis and trying to link it with data that comes before that. So I'm going to go ahead and skip over a bunch of these sections and jump straight to the housing recovery model. So I've got a bunch of text written so that as people are coming to use this model, they can fully understand what's going on, some of the caveats and buyer bewares that you need to be considering when employing the model. But you can kind of see my sections. I prepare the data and then get into the analysis. So in terms of preparing the data, we're reading in, or at first I've got a definitions of each of the variables that are needed, the data sources that are where they're coming from, and we've kind of already talked through some of that. What data are coming from prior analyses in this changed analysis. So talking about what data are we able to lift from prior sections in this notebook, what data doesn't exist in the notebook that I'm having to bring in at this stage, and then some additional housing unit characteristics as well that I got to bring in. So I read in the population dislocation result. That's each observation there is a is a housing structure that I can use. So each row is going to be a housing structure. I clean the data. I need to create a owner occupied dummy variable. You see just a lot of code to do what I just said. Keep only single family parcels. So we want to get rid of all multifamily and other housing types. So that's just dropping those observations. And then we want to identify the housing market. So what is urban core and what is seasonal vacation? I'm going to skip over that because what's really employed is what I talked about in the slide deck of using a 50% threshold. So if the census tract has 50% or greater seasonal vacation housing units out of total housing units, we consider that a seasonal housing market. If it's less than 50%, then we consider that a primary housing market. And this just kind of gets into how we're taking the census tract data and coming up with those percentages, merging those census tract percentages with each parcel, and then determining if that parcel needs to use the primary housing market model or the seasonal vacation housing market model. So I've done some census API requests to get that additional information that we need, convert those counts into percentages. And that's what's kind of going on through here. Reading in, and then so after you get done with that, then reading in the block group level median household income data, read in additional building information. So reading in all those data sets and then finally merging them all together. So taking what we have from the population dislocation result, the additional data, and then the seasonal vacation housing census ACS data, and merging those all together with some additional cleaning. So this is all pretty much cleaning. I'm going to jump down to this estimate value loss section. So for each parcel, we need an estimate of damage. It's a coefficient, a variable in the model. So in the original paper where we were describing, or where it was describing what was happening in Galveston, we were looking at the difference between 2008 and 2009, before the storm, after the storm, and the difference in building value is the damage, the estimated damage. But if we're chaining the analysis within this notebook, we're basing that off of this Tomachek et al. And then by UC Gardoni, 2009, kind of those two together to come up with a value loss estimate. And so once we come up with that value loss estimate, then that becomes our input for the damage parameter in the model. So just to show, I do want to show this comparison. This is kind of some of the issues that I was talking about earlier to not to read so much into those predicted building values that we saw in the PowerPoint. So here's the distribution of damage, percent value loss on the x-axis, density on the y-axis. So that's the distribution of damage based on the empirical results from the tax assessor data. Using the Tomacek et al. and Bai et al. Method for producing a value loss. This is the distribution, the estimated distribution of value loss from that. And you kind of see how it's bimodal, and that's because the Tomacek predicts the collapse or non-collapse. So we don't get this kind of continuous distribution of damage and value loss. So just something that kind of skews the results more. Here, I guess in the notebook, it was not so much about producing reality, but more so proving the concept of being able to link to other analyses. Now the next steps are to improve the input data into the model to get better results. This is just a scatter plot showing between value loss and damage, just to see. But so just for sake of time, I'm going to keep kind of charging forward. So now we're just getting into just showing, okay, again, for each parcel, what variables are needed to predict building value change over time. So these were the variables, and then getting into the actual analysis. So this section of code is the coefficients stored in dictionaries that we later use kind of in just a multiplicative additional additive formula to come up with predicted building values. So these are the coefficients for the primary housing market model, coefficients for the seasonal housing vacation model, and then we get into estimation, where you take for each parcel, and then the input parameters or input variables values for each variable. You multiply that through, so for each parcel, you get these values, you multiply them by the coefficients, and then you end up with a predicted building value per year. Scroll down, and again, these are essentially what I copied and pasted into the PowerPoint. So you get that prediction per year. We can convert that prediction to an index, and then you can multiply that index times the base year to get a prediction based on the index per parcel. So I'll switch back to I guess I do want to note, yeah, so out there, the housing recovery model has been converted and ported over to InCore. So taking all that code and kind of packaging it up into discrete functions. It's out there. Just you click this link to, you get an abbreviated notebook of what I just showed with all that extensive code, but just really what's needed to prove out the housing value recovery model. Again, you got the building damage, you've got the housing unit allocation, population dislocation analysis, because we need the population dislocation result to feed into the housing recovery analysis. And then these sections of code essentially take everything that I showed, those hundreds of lines, and just really shrinks it down and makes it much more simpler. And that's a nice thing. So I think last slide that I've got. So those are the two notebooks. And then next steps are, I do need to go back and clean up some of the text, the code, and the output in the production notebooks on GitHub and InCore. So, preparing for this meeting and going back to there, I think there's a lot that can be improved upon, rewritten so that it's more user-friendly. Add the analysis to the Galveston test spec notebook. So just, bring in what I've put in my notebook and showed you as an example, but actually put that into the Galveston testbed notebook so that it's out there for everyone to look at it. improve upon some of those value loss estimates, the damage state prediction, and use the household and housing unit allocation inventory. So to produce better estimates, replace that bimodal value loss with some of the better damage state prediction models that I believe are coming from Omar. So doing that. And then linking with the CGE model, and then, kind of slightly touching on what Jamie was talking about earlier. This was one model that was for the Galveston Hurricane Ike case. We want to be able to build additional models so that we can account for those varying, event level macroeconomic differences across events, across situations or scenarios that you want to be able to predict in. So include those so that we can definitely account for those, such as differences in financing, differences in just community characteristics, and then other housing types as well. We're predicting single family housing, but to be able to predict 2 to 4 unit, multifamily, and other housing types as well. So that's essentially what we've got that's out there, and that's the end.